graph an ellipsoid today. We have this expression right here, and basically this is going to give us a three-dimensional graph. So this will be known as an ellipsoid, which is basically just an ellipse but in 3 dimensions. So we are going to have to graph this. So let's go ahead and do this. So let's first rewrite this as x squared over parentheses 1 over 3 squared. Now if you're confused as to how to get this, like this part to this, that's right, I'll show you. So we have x squared, right? And let's divide by 1 over 9. This, divide this, and you'll see that you'll get this. So when we divide this, it's x squared. Remember, when we divide fractions, it's keep, change, change. So keep the x squared, change the division to a multiplication, and get the reciprocal of this 1 over 9. So it's just 9 over 1. And this will give you 9x squared. This is this. So that is why we are dividing it by 1 over third. 1 over third, basically just take the square root. The square root of this, so it's so 1 over third equals 1 over 9. 1 over third squared equals 1 over 9. So that's where I'm getting this from. So in case you're confused as to where I got that. So go ahead and rewrite this term as that one. Same, we can do the same thing here. So plus y squared over what? 1/2 to the second power. This we don't need to do anything, so just plus z squared equals 1. That's a square, by the way, that's a z. Z squared equals 1. So basically now we are going to have to find where these points lie on the planes. So let's go ahead and let's do the x and y plane first. X and y plane. X and y plane. So for the x and y plane, we're going to let k is going to be a constant, so any real number, right? We're gonna let k equal z, right? Let k equal z, because for the x and y plane we need to get rid of z. So let k equal z. Let k be a constant that equals z. All right. So and now we're going to manipulate this. So now we have x squared 1/3 over 1/3 to the second power plus y squared 1/2, so to the second power, equals 1. Now we're going to subtract z. Well, it's k now. We're going to subtract z from both sides. But remember, z is k now, so minus k squared. So minus k squared. Look, it doesn't have anything at the bottom. It just has an imaginary number 1, right? So let k equals z. So what does this look like in a 2-dimensional plane? It looks like the equation for an ellipse, right? So this we'll call an ellipse. Ellipse if k is between what? -1 and 1, right? So this is basically just an ellipse. If you need a refresher on ellipses, go watch a video on ellipses. But I'm not gonna go too depth into them right here. So yeah, ellipse if k is between -1 and 1. So basically just take the square root -1 and 1, right? Okay. So go ahead and copy this down because I'm gonna have to erase it now. So let's erase it. That's your x and y plane. So go ahead and copy that thing down. So now let's go ahead and do so we did x. We're gonna do the yz plane. So yz plane, we're gonna have to let x, right? X this time, k equals x, right? K equals x, this time for the YZ plane. So again, y squared over 1/2 squared plus z squared. 1 minus this, right? But remember, this turns into a k. 1 minus, because you're just subtracting this from both sides. So this is k squared. And we do have a denominator, 1/3 squared. And again, this is the ellipse formula. So ellipse, if k is between, what's here? Square root of 1/3. I mean, yeah, square root of 1/3 raised to the second power. Negative 1/3 and positive 1/3. All right. Good with that one. Copy this down and let's do the last one. So now we have the xz plane, right? So we done the xy, we done yz, right? We done yz, now xz. Xz plane. So let's see. So this is we're gonna let k equals to y. Same thing applies. So where's y? We're gonna subtract from both sides, and remember y turns into a k, so that's x squared divided by 1/3 squared plus z squared equals to 1 minus this. This k, but remember y turns into k. K squared 1/2 squared. Again, this is the ellipse. E for ellipse if, remember, this is the ellipse formula. Looks like it, right? This is a constant. Remember, that's a constant. Ellipse if k is between negative 1/2 and 1/2. Okay, so now we're ready to go ahead and plot these on the 3D plane. So I'll be right back. So it looks pretty bad, but that is how, this is our z-axis. That's 1, that's -1. Here's 1, and I divided the x. Oops, I forgot to hold on. Whatever. If you're familiar with the 3D plane, this is the x-axis. All of this is the x-axis. All of this is the y-axis, and this is the z-axis. I did not label them, but that's alright. So hold on just a second. Hold on. Right now I did label them x, y, and z. So remember, when k is equal to z, it's an ellipse if k is between -1 and 1. So this is our z. You go to your z-axis. Here's -1 and here's 1. So go ahead and plot points here at 1 and then -1. And this is from the work we just did. So I just summarized it up here. Now, if k is equal to x, or k is going to be between -1/3 and 1/3, positive 1/3. So go to x, and this is 1. I divided it into 3 parts, 1, 2, 3. So 1/3 is going to be here, and -1/3 is going to be here. So let's go ahead and put our points. So that is 0, 0, 1. That would be 0, 0, -1. This is 1/3. 0, 0. That would be -1/3, 0, 0. If k is equal to y, k is going to be between a -1/2 and 1/2. So this is -1/2 as 1/2. So this is going to be 0, positive 1/2, 0, 0, -1/2, 0. Okay, so now let's go ahead and plot our, trace over the points. Let's see if I can actually do this. It's gonna be really messy, but you guys get the gist. Alright, so Everything seems good. Okay, so that looks pretty bad, but I'm sure if you were to graph this in like a graphing calculator that can do 3D graphs, then it will look a lot better. But this is basically the whole gist of it. This is what we call an ellipsoid. So yeah, that's it. Yeah, that's it. Yeah, if you have any questions, just let me know. I'm planning to do another one because I want to do another example. So I'll hopefully do another one pretty soon. So that's it.